unless the 96 well plate has a sort of a cover slip bottom. There are 96 well plate with they tend to use a film or something like that is thin. But if it's a normal one with the plastic bottom, then you would need, in this case here, either the 5x, which would typically be too low magnification for most practical thing. It's good to get overviews and so on. We will see what that can do. But you would be using the 40x objective. So if you do realize that you need, I mean, you have space for other objectives in the future to add. So we started with this to give you this. These objectives will work for a quite wide range, but you can of course add if you realize that you will need something more. So this 40x objective that we have on here, we have a corresponding as a 20x, which is also very common to have, especially if you're working with a lot of 96 well plate with normal plastic bottom. So that's also possible. Okay, so I will now start to see if I can find my sample here. I put the 5x there. I will need to start something. So now I will sort of set up a channel, basically. So to set up a channel is what I mean by that is to set up for what I want to look at. On this sample, we will have there are cells, and they have DAPI, they have Alexa 488, and they have Alexa 555, I think it is. That means that there are blue, green, and red, more or less. So that's what I will set up here. So we can build it from scratch, which is what I will start by doing. So we set up a channel in this middle window here. We start from the top and work our way down. Start by choosing what type of contrast methods we will use. We have bright field, fluo pH, which is always there, but it's not useful here. So I would prefer it wasn't there, but the software always has it there. So we have bright field or fluo, basically. So I will do fluo here. Next step is to pick both filter cubes, and also we have to set up the light source. So this light source, the P4000, is a multi-channel light source. It's built in a way so that it has let's say four lines. Each line has an additional 4 wavelengths in it. So this line here, we can have wavelength around 365, 385, 405, or 435. So you would have to choose that. The same thing here, and the same thing here, and the same thing here. So each of these have 4 lines. So that means you have 16 possibilities here. So in this one I have DAPI. So DAPI, a lot of people would use 365, but in this case you also have to consider to match this with the filter cube that you're using. So we have 2 filter cubes. If you hover on these, you will see what they are. Are you familiar with reading this text that is coming up there? EX375-407 and so on? Okay, so what this means is that, let me do this. So all of these things could be easier if you are snippet tool. Do you know this one? My favorite tool in Windows when I discovered it. So this here tells us about the wavelength. So this is a quad band, so it has 4 bands. So each of these are 1 band for the excitation. So in this one you will have excitation light between 375 and 407 nanometers. You will then have 462 to 496 and so on and so forth. So for DAPI we will be using this window here. So we need to match this window with the numbers we have here. So for DAPI I would use probably, so you have 365, 385 and 405. I would probably use the 405. You could also use the 385, and you could test which one will give you the better signal. And we can do that already, and to see which one matches best here. So actually the 385 could be better, but we would have to check, because also all these LEDs have slightly different intensities. I wanted to open up, hold on, I can open up this one here. So this is the way this light source is built. So it has a lot of these lines you see here. So the 365 is this intensity profile. So just because it says 365 doesn't mean that it's not a laser. It doesn't have just the 365. It would be a little bit of a spread around that number. Okay. So the same as in the excitation window here. So this is what I mean by matching the line with the fluorescence filter. Okay. So that is something to keep in mind when you do this. There is also safety built into LSX, meaning that, so now I have this cube selected. So this is the cube for basically DAPI, FITSI or Alexa 488, Sci3 or Alexa 555 and so on, and Sci5, for example, and anything similar to that. So when I have this selected, and now we have these lines available, 385, 460, 525, and 635. This is the only one that I can also click on this one. I can activate this, and I can activate this, but these ones I cannot activate. The reason for it is that 525 doesn't match with the window there in the middle. Let's open up that one. So the 525 doesn't match. It's outside of any of these excitation windows. So I'm not allowed to choose it. So that's a safety thing. So you will only be allowed to choose to activate a line that is matching with your filter. So if I would change this to a 470, then I'm allowed to choose it, because the 470 is in that range. The same thing with this one. If I would go to 550 here instead, I would be able to choose it. Okay? So if I want to do a DAPI now, I would say that, okay, I want to have this cube, which will contain DAPI. I will activate the 385. I only want that. I don't want the other lines activated. And I will set up a percentage here. So this is the intensity, 100 to 0. So I will start somewhere maybe around 10. So now I've chosen the DAPI cube, the quad cube that contains DAPI. I have my excitation light. I know that it's fluorescence. So let's go live and see what happens. So I can see that the light is on because I have light here. You can see it. So everything is working there. But here it looks very, very dark. I can increase this and I'm starting to see something. So this is then all the nucleus. This is a 5x, so it's not very strong. So it looks like I'm more or less in focus. I can change the focus. You can see that I'm moving out of focus and coming back into focus. So I was in a pretty good position here with this. Very good. So I found my sample. I want to continue to set up my different channels now. So this was the DAPI. If I want to now add, you saw also that this was black and white here. We'll do this now. So you see here that this is black and white. I can give this a color also. That's up here. So that belongs to the whole thing of setting up my channels. This is the lookup table that I will use for this channel. Right now it's grayscale. If I double click on this, I get a bunch of different colors to choose from. DAPI, most people use blue, so I will use blue. You can use whatever color you want. So I will put blue. So if I have that blue, and now I go live, then it will be blue. Okay. So I will continue. That was the DAPI channel. I will add a channel by clicking this. This now, I want to be my Alexa 488 channel. So So first of all, I do not want to have the 385, the DAPI active, so I will click on that, get rid of that, and instead I will activate this one. And here again I will take a little bit of intensity. It's already automatically picked the green lookup. I can double click and I can choose something else, but I will leave it at green because that's what you typically would have for this line. I go live. So here we can see our 488 stain, which is acting in this case. It doesn't look very good now because still the light is on and so on, and we're on the 5x, but we'll just go through this and then we'll see when it looks better. So that's my green channel, and I will continue over to my red channel. So in the red channel, I don't want to look at the 488, so I don't want to have that excitation light, but instead I want to have 555, which is the one that corresponds to this channel. So I will activate that, and we'll drag this up, and we'll start to see that stain coming through. So now I've set up my 3 different channels, and I have found my focus. So with the 5x, I think for you guys, some people, they of course use the 5x to image. With cells, I would use the 5x for maybe just finding my sample, getting an overview or something like that. So I found my sample, I have found the focus more or less, so I will actually change now to the 20x to get a bit better images. We'll also turn off the light if you're okay with that. And when you work, I would also use, so with wide field is a bit more sensitive. I don't know if any of you use confocal. Confocal, most of the time you sit in a very dark room to work, yeah? Not necessary. Because for confocal, the whole structure of confocal is built so that it only collects light that comes from the point in focus. So actually when you work with confocal, it's not as crucial to work in a completely dark environment. With wide field, it doesn't have that pinhole that you have in confocal, so this one is more sensitive for light around. So when you work with wide field, it's more important that you try to darken things around. So in some cases, if you sit here and work, if you have a sample with low fluorescence and so on and so forth, even having his door open could make a difference, potentially. So, but if you have, in some samples, they would look equally good with all the light on and so on. So it all depends on the sample, but it is more sensitive. Okay, so let me go back. I can see if we can see this just by turning off the lights here. If I go and see live here, you saw now that it disappeared those things that were around here. So that's actually these light bulbs. So this is actually the light on top here coming through. This is probably crap on the slide there. But let's move to the 20x instead. 20x, we fine adjust the focus a little bit. So already with the 20x compared to the 5x, it's starting to look much better. Yeah. So here we have our red stain. We can now move between these different channels by simply clicking on it. So we're looking at the red, going over and we're checking the green, and we're moving over and we're checking the DAPI.
The red channel has a way higher intensity of the laser right now. It's at 60% compared to 11 and 19. Is it just due to the flow form?
Yeah, this is, it all depends. So we're going to come into this different settings and intensities that we want to have here. So we can have that discussion now. So you want to have an image that looks nice. That's one thing. If you're going to do downstream analysis, you also want to have an image that will have a good enough quality for your analysis that you want to do downstream. So you have to have those two things in mind. What are you going to use the images for, and what type of quality do you need for that? So right now, let me reset this part, and we're going to talk about this part. This is now my raw data. This is what the camera sees. I go live now, so this is what we're looking at. Kind of dark. The green one here, this is what we're looking at. This is from the camera. And the DAPI we still see. The DAPI is typically very, very strong stain. So typically it's very, very bright. So now we're going to talk a little bit about why this is, and we're going to talk about the camera. So this camera is a scientific CMOS camera. It has something called 16-bit depth, which basically means that it has, as you see here, 65,535, or actually 36, levels of gray. So it actually collects all the pixels. They are collecting light, and it's dividing up, when you look at the intensity, it's collecting up the amount of intensities over 65,536 levels of gray. So to fill this up, to fill up like the whole dynamic range of this chip, we would have to have quite a significant amount of, we're going now, it's still quite dark here. We're getting to 1 hour, 1 second's exposure. We can go a bit higher here, maybe increase this also. So when we're getting here, somewhere here, we have maxed out on the these ones. Let me just check something. One setting that I checked yesterday. So if I'm using now the camera and I'm using the full dynamic range here, I will need to have maximum intensity of the light source. I have 1.5 seconds of exposure, and this type of experiment is not very good. So this will not be good in a practical way. And this is what I will get. Let me just take that single image. Okay, so there we have that one. If I go live now, this is what I will looking at. We'll drag this down to a more reasonable, like say somewhere there, 100, 150 or so. It all depends on your sample. And we'll drag this down a little bit. Let's go down to say 30. So now I'm not seeing anything, but I can rescale this, which is dragging this one down. Do you know what I'm doing right now? Okay, so now we can see that it's starting to appear here, my sample, and I can see something. I can also drag this guy here the other direction, and all of a sudden I have a pretty nice image, right? So what I've done here is that I have basically just told the camera which intensities to display and how to display them. I'm gonna let's take I'm gonna open the histogram that can help to illustrate what we're doing here. Have you seen? Do you know what a histogram is? So a histogram here. And with fluorescence, it's, let me open up the old image, maybe that one is, yeah. So here we have the image that I captured with this 1.5 second exposure. So the histogram here shows me basically this image, but without the spatial information. It just shows me the number of pixels, this is the number of pixels, with a certain intensity. So this one tells me that right here, we have a lot of pixels that has the intensity here, somewhere around, I don't know, 100 and something. That's the background, most likely, in this one. So all those pixels are here. All of these ones, all the red that we actually see something, is probably this bump here. So all of they have, most of them, they will be of intensities around this here. But the camera can show intensities up to 6,553. So what we can do now, we can rescale this, meaning I can drag this down see, as I drag this one is moving, so those two are the same thing. So what I'm doing here is that I'm telling the software to any pixel with the value of, what is it, 8,907?
Yep.
Any pixel that has that value should be shown on the display as fully red. Yeah? So now it looks much brighter here. My raw data, the capture data, looks like this still. Doesn't matter. But it just helps me to see this better. And I can do the same thing on this side. So right now, if it has a pixel value 0, it will be shown as black. But I can drag this up a little bit and say that if it has a pixel value of 650 or lower, show it black. And now all of a sudden my image is with a much higher contrast. And again, this is just for the display, for you to see.
And how can I see that whether my image is overexposured or not?
Yeah. So overexposure or underexposure is very important. So I can do that with the top button here. We have over and underexposure. If I click that once, this will show me now anything that is, okay, let's use the terms over and underexposed still. So overexposed pixels will be shown in blue, bright blue. Underexposed pixels will be shown in bright green, as you can see down here. But something to remember here, so this is the underexposed color. Something to remember here is that we rescale this. So actually these warnings are following my rescaling. So what this means is that right now all the pixels that has a higher value than 9,752 will be shown as bright blue. But what you need to remember is that your raw data is like this. So in this image, nothing is overexposed. But this warning can help you to gauge, okay, so we're starting to get this point here is our brightest point in the image. Because that one is starting to be blue first, yeah? And then other things will follow. But so there I have my brightest dots. So this can be help to sort of decide like where are my intensities in the image, because this is something that will be important to decide, is this quality and my settings good for what I want to do afterwards. The same thing with this one, we can also sort of get a sense of where is the background, how. So it seems like the pixels starting around almost 1,000 or so, 800. So this over and under exposure was this one, and this one has 3 positions. You click once, you get into here. You click one more, you see the grayscale image, and you click one more time, you get back to the lookup table that you have and the color that you chose for it. Okay, so doing this rescaling, as I call it, this is something that you should definitely use when you have a camera like this. So this camera is good, has a high sensitivity, and it has a pretty good and low noise. So this means that you don't need to use the full dynamic range of the camera, meaning that you don't need to fill it up all the way up to here to have a nice, good quality image. You can also use just the bottom bit. So this is the image that we took with 1.5 seconds. I will compare that with the one we took using just a fraction of that exposure time. So to look at another image, I will open another window. So now we have 2 windows. We can also resize these. So all these windows you can resize by dragging these things a little bit. This is this image, and here I will open now a different one. So I'm going a little bit ahead of things I haven't shown you just yet, but bear with me. So this is the image that we took with different settings. And if we zoom in at these two, I think, we zoom in these two, I think you will see that it's quite difficult to distinguish these two in terms of quality. So this one is the image 001, this one is image 002. And you can see that they have very different scaling. So this one here is 807 there, while this one has 23,000. But for viewing purposes, it's not a very big difference, right? This one was with 1.5 seconds exposure, full intensity on the LED, and this one had a 30% and 150 milliseconds exposure. So what I want to show here is that do not work hard to fill up the full dynamic range of the camera. It's unnecessary, and it will lead to very long exposure times or unnecessarily high intensities on your sample. So the other then natural question comes in: what is a good number here? Like what type of intensities would I be looking for? And that's definitely up to what you're gonna do downstream. I would say that this one would be enough for if I wanted to show, like visually, look at my sample and decide something. Analyze it with my eye to see something. I mean, this would be enough. If I'm gonna do an analysis of this, it would depend on what type of analysis and what the software I'm using is. So I can't give you just a, like, this is the intensity you should always go for. Something you need to work out yourself. And it's also related, of course, to the background. Like, how high is my background? You're very often talking about like signal to background or signal to noise. So what I can say in general, my own rule of thumb, if I don't know what I'm gonna do afterwards, I feel quite comfortable if I have intensities on my signals that is around maybe 1,500 or 2,000. I wouldn't have big problems going below that. It also depends on the background though. But so again, images with an intensity of about 2,000 compared to the 65,000 that we have here. So don't be scared to use a small piece of this. A quick way. So we started looking at some of these buttons here. And I'm not using a lot of these buttons. I'm using this one, over and under exposure, and I'm using the autoscale very often. The autoscale is a quick way to get to a point where the contrast is fairly okay. This is the software analyzing the image and just rescaling this to settings where it finds pretty good contrast. So this one I also use. I use it especially in the beginning when I try to set something up and trying to find my sample, because if I am, let's go live here. If I'm very much out of focus here, you see that right now, if I had set this for somewhere here, I might not see anything until I'm really in focus, and then maybe I would see something. Or if I'm moving around on my sample where I don't have any samples. But if I have clicked this one, it will be very fast where you see something. Oh, okay, here seems like I have something, and then you can find focus. I use it for that too. It's good to use when you're trying to find your sample. So with all of these, I tend to use these two buttons, over and under exposure and autoscale. Once I have my scale that I think this is good, I untick this. What is important to remember when you use this, because you can't get fooled. When you start adjusting settings here, you might think, oh, it still looks pretty good. But just remember to have a look at this number and this number, so that you see, because this could be at 300, meaning that you have very, very few levels of gray, but on the display it looks fine. So when you're doing these rescaling and so on, remember to just have a look at where are my intensities, are they high enough? for what I need and so on. Okay? Any questions there? Okay. Okay, I'll show you one more thing before we take a short break. Just a stretch and maybe a quick coffee, and then we'll do another hour roughly before lunch, okay? And what I wanted to show you was what I clicked on for a little bit there. So we'll jump we've looked at this window here now a little bit, we'll come back to that more. But I want to go over here because we looked at some images, we opened images and so on. So in this tab here, Open Project, this is where we have our file handling. So if I click on this, this is where I will save all my images. So whenever you start so whenever you start up the software and you go live to see an image or something, LSX will always start a new project. So the way LSX is working as something we call it projects. So this project will be created, and then whatever images I capture will be captured under this project. So you see I captured this one and this one so far. And if I would capture another one, it will end up under here. Okay? So this project is what we call a LIF file. That's a Leica image file. So that's a format, the standard format for Leica images. So we can call it like a container, and in this container we're gathering all our images and everything that we do during our imaging session. So in the end, when I save this, I will not have 3 files, but I will have 1 LIF file. And in that LIF file, I will have my 3 images, or 100 images, or how many images I'm doing. But while I'm working now, this is not saved. So here you have a little diskette. So this is not saved. It's temporarily saved on the hard drive in something called a data container. So whenever you work with LSX is always, as soon as you start working, it saves everything to something called a data container. It's a temporary part of the hardware where everything you do just goes into there. And then at the end of your session, if what you've done during this session you want to save that, you will click this Save Project button. And you go into Save, and then you can save it as an image file somewhere. Give it a name and so on. If I try to close this, it would also give me a warning. This has not been saved. Do you want to save this project? So as long as I remember to save it, then everything is good. So to access what I've done, I can just go into Open Project. I can see all the images that I've taken. But here I can also create a new project. If I'm sitting here working now, I'm gonna start with the new samples. I've got a new project, so I can click on this New Project tab here. And now if I start taking images, they will go into the new project. If I go back and do something with my old project, I can always go back. As long as that is highlighted, whenever I take an image, it goes into that project. So this whole thing is like the file management system of basically any computer. These are folders. Within the folders you have images. Okay? These names you can change by just clicking on them. You can call them whatever you want. The same thing with the project. You can click on it and you can call that anything that makes more sense to you. You can also, if you know that, okay, I'm gonna take 50 images of this sample and I don't want them to be called image 001 and so on and so forth, I can go down here, project settings, and I can use a user-defined image name. So here I can now make a name that makes more sense to me, maybe underscore at the end. Okay, so this is now a different keyboard. Let's do a hyphen instead. Oh yeah, so this is a Swedish keyboard, that one is probably in English. So I do a hyphen. So this now, whenever I take an image now, it will give it that name, hyphen 001, and then it will continue from there. So that's a way of giving it a name that makes more sense to you, so you don't have to rename everything. Okay? So that's user-defined image name. I will remove this for now. You can also, if you want, go into the project. So the main thing up here, and you can, so the default name will always be project. In a multi-user facility like this, I tend to leave it there so that everybody gives their own name, but you can also have the default name being something else if you want. You have an autosave function. So you can, as I said, in LSX, default is that you work with it and everything is saved into this data container, and then at the end of your session you click save and it saves it. Yeah? You can activate an autosave. You can say where you want to have that saved and which type of data. You can autosave it into what is called LOF. LOF is a LIF file, but with a different structure. So this is a Leica file. You have TIFF, JPEG, and so on and so forth that you can autosave into. The autosave function, because this data container is like an autosave function, so if you're sitting here working and there's a power outage, everything closed down, and you've been imaging for 4 hours, then with the data container, when the power is back on, when you open up LSX, it will load up that last data container. So your data is safe, always. So this is why you don't necessarily need the autosave. When the autosave can be good, I would say, is if you're starting to work with huge samples. Say that you're gonna take a gigantic tile scan that will be 500 gigabytes of data. At that point, I would probably do an autosave, because then it will save as you're imaging this. It will take quite a while for it to image, but it's continuously writing that to the hard drive. Because if you take a 500 gigabytes into the data container and then after you're saving that, then it will take a while. So maybe if you're working with huge files like that, but otherwise, I think to begin with, use the LIF file. Don't use the autosave, but just work with it like this. Again, you can always read more about it. You have the little eye here, so you can read more about the autosave. You can also have the eye here to read more about the file handling of stuff, the project settings, and user-defined image name, and so on. The last thing I will show you before we take the break is, this is like a file handling software. So I can take this one, I can drag it over to this one. So I can move images between projects. I can also copy, if I want to make a copy of this image, so I want to have it in 2 projects, I can copy this, and I would go here, and I would do paste. So then I have that same image in both of these projects. So you can move things around between, you can move it, you can copy, paste it, and so on. So one thing is, if you're sitting here, you're doing a lot of imaging over several hours, you have several hundred images, but you know that, okay, I want to save 10. You can either delete 90, or you can just take those 10 and create a new project, drag them over, save that project, and not save the previous project. That's also a way of doing it. So, yeah, it works like a file handling system, basically. Okay. So I think I will stop there. We take questions and then we take break. Yes?
Just one question. When we save our project now, we can probably also change the file type to TIFF or something like that? Or do we have to export the...
So I would, when you save this, you have here only these Leica options. So that's for saving it. I would recommend to save the LIF file and have that as your sort of raw data, because that also has all the metadata, everything that was, everything about the light source, the settings, and so on.
So it includes all the settings which I set up for this specific. So I can basically also open my project again and then run the exact same settings on the new samples.
So if I remove these ones now, I open up this one and I wanted to do this this image again, or have the same setting. I can right click here and go apply image settings, that will load up the exact settings that I used for this image.
Yep.
So that's good. So instead, I would always use the LIF file as my sort of raw data. It's also very easy because it's one file to move around and so on. And then I would export. And you can export single images, so I can right click, do export image. This one here. You also have the little eye here.
Yeah.
Where you wanted, which format, and here you have a few different formats. It also asks you, I mean, if it's a multi-channel, it will give you, now it's just one channel, but you have all these settings. And typically when you export something as TIFF, you want the raw image. So it's the raw image. The scale viewer image will be an RGB image, 8-bit of this, what you see.
Okay.
Good for presentations or stuff like that, or if you're gonna send an image for someone just to, like, look what I found, or what is this. But for analysis or anything afterwards, opening up in different software, a raw image is better. So you can do that with single images, but you can also go just to the top and say, I want to export this project. So this, if I do this, it would export the entire project as TIFF.
Okay.
So you can do both of those.
Okay.
And
So
that's single images, right? So it would not contain all the, I don't know, 4 channels.
No, so this would export it as I mean, you have the option here also, save as multi-page. So the TIFF you can save as multi-page TIFF if you want, or not. So it's an option that you have there. The thing when you do the whole projects, this line of which channels to export, you don't get that because with I mean there'll be different with different images, so it will always export all of it. So, yeah, so I would always use the LIF file format for your images and then export the things that you want as TIFF and analyze somewhere else like that. LIF files can be read by several third-party analysis software that you might use. You could check it with them. Avia is one that will read the LIF files. Imaris, if you've heard of it, it's another analysis software, will read the LIF file. ImageJ, you can also have them read LIF files and so on, so that's possible. If you want to open up and check your images on your own computer, you should install LSX, which is free. You can install it, and then you can open up and work with those images also on your computer. Cool. Should we have a break?
Yes.
15 minutes.
Okay.
And then we come back. I will be back a little bit before, I think. So if you have questions.